Hi everyone, this is Anurag. Today in this session we are going to discuss about storage management. So let us see what is meant by a storage management. So this is our database. In this database we store the data. Data in the database is stored in the form of three files. Those are control file, redo log file, and also third one data file. Okay, about these three files we have seen in architecture. Okay, see this control file, redo log file, data file, all these files will be in binary format. Binary format means we cannot open these files, we cannot read the data in these files. So how to access the data in these files? Okay, through logical objects we can access the data by using a table space. What is a table space? Table space is a logical representation of physical data file. Okay, to access the data in a data file we use a table space. Okay, how data can be stored in table spaces, how data can be reorganized, that we are going to see in our storage management class. Okay, the basic building unit in a database is Oracle block. Oracle block. This is the basic building unit. The sizes of Oracle block will be ranging from 2K, 4K, 8K, 16K, 32K. Okay, these are the default block. These are the block sizes of Oracle block. By default, the size of the Oracle block is 8 KB. Okay, so the hierarchy of how data can be stored in a database can be represented in a keyword called as best. What is meant by best? B stands for blocks, Oracle blocks. E stands for extents. S stands for segments. T stands for table spaces. Okay, a combination of Oracle block is a extent. Combination of extents is a segment. Combination of segments is a table space. Here segments in that sense, employee table, department table, like this. Different tables are treated as different segments. For each segments, blocks will be there, extents will be there. Let us see that structure. Okay, by using the simple command called as best, we can remember all the hierarchy. Why? Because people may confuse us. Is extents is a combination of segments, or segments is a combination of extents. So by using this keyword we cannot forget the hierarchy. Okay, Oracle blocks is a combination of extent. Okay, combination of blocks is a extent, combination of extents is a segment, combination of segments is a table space. Okay, so what is an extent? For example, whenever we create a table, okay, whenever we create a table, employee table or any other table, a extent will be allocated. Okay, this is a extent. Okay, in each extent Oracle blocks will be there. Okay, minimum 5 blocks should be there per one extent. Okay, these blocks are also continuous blocks. Continuous blocks. What is meant by continuous blocks? Suppose there are 5 extents, 5 blocks. In this is filled with data, this is filled with data, this is filled with data, this is filled with data. This is the extent, but it is empty, it is not containing any data. Can we group this into a extent? No. The combination of continuous Oracle blocks is only extent. If here blocks are not continuous, middle block is empty, so we cannot treat it as a extent. Understood the concept? Minimum 5 extents should be there per one extent. Minimum 5 Oracle blocks should be there for one extent. Suppose we have created an employee table, we have inserted some rows. These blocks will be filled with the data. Okay, like this, when this extent is filled with the data, one more extent is allocated. When one extent is filled with data, another extent will be allocated. Okay, this is called as dynamic space allocation. Shortly call it as DSA. DSA stands for dynamic space allocation. Okay, when one extent is filled with data, automatically another extent will be allocated by the oracle. This is called as dynamic space allocation. So based upon the storage management, table spaces are divided into two types. Okay, what are those two types of table spaces? Let us see. So locally managed table spaces and dictionary managed table spaces. So table spaces are divided into two types: locally managed table spaces and dictionary managed table spaces. What are these dictionary managed table spaces and locally managed table spaces? Let us see. In earlier versions such as 6i, 7i, dictionary managed table spaces used to be there. So what is the difference between locally managed table spaces and dictionary managed table spaces? Let us see. Before that, locally managed tables, we will see in locally managed table spaces two modes will be there. One is auto mode and other is uniform mode. What is the meaning of these modes? We will see. Okay. So there will be some, let us see locally managed table spaces. Okay, whenever there is a table, suppose there is a table space called as TS1, in that we are creating a employee table. This employee table is treated as a segment. Okay, whenever in segment extents will be there. Okay, whenever we insert one row, automatically extent will be created. This is first extent. Okay, here we will discuss locally managed table space automatic mode. What happens here? Let us see. Okay, first an extent will be allocated. In that minimum 8 blocks will be there. Okay, each block size is 8k. Like this 8 blocks will be there. Entire size of this extent will be 64k. One extent size is 64k. When we keep on inserting rows, these blocks will be filled. When this extent is filled with data, automatically one more extent will be allocated. Okay, automatically one more extent will be allocated. This is called as dynamic space allocation. This is also size 64k. 8 blocks will be there. Okay, like this, the first extent size is 64k, second extent size is 64k. Like this, if we keep on adding the data, keep on extents will be allocated. Like this, when extents completes 16, okay, this is first, second, like this, when 16 extents are completed, what will happen? 64, 128, 256. Like this, when sizes of all the extents reaches 1 MB, okay, here size of extent is 64k, here 64k. Like this, when 16 extents completes, the size of all the extents, the sum of sizes of all the extents will become 1 megabyte. From then, extent will be allocated with the size 1 MB, then 1 MB, like this. Okay, this automatic increasing of size of a extent is possible in locally managed table spaces. Okay, this is about locally managed table spaces auto. Now let us see locally managed table spaces with uniform option. With uniform option. Here extent is there. In that, whenever we create a segment, okay, we insert values. Minimum 5 should be there. Okay, this is one extent. Here we will mention the size of the extent. For example, if I give size of extent as 40k, that means entire size, only 5 blocks can be created. Okay, why? Because each extent size is, each block size is 5k, 8k, so 5 blocks can be created. Okay, when this 40k size of extent is filled with data, another extent will be allocated. It is also of size 40k. Like this, how much you insert data, those many extents will be created. even though it creates 200 extents, this is, for example, this is 200 extent, its size will not change. Its size is 40k itself. Previously, when size of all the extents, sum of sizes of all the extents reaches 1 MB, then next extent size will be 1 MB, 1 MB, 1 MB, it grows like this. But in locally managed table spaces with uniform option, the size of extents will increase. Okay, when first extent size is all the extent size will be uniform. There won't be increasing or decreasing in the segment extent size. Okay, like this, if we insert so much data, so many extents can be allocated. This is locally managed table spaces. Now we are using locally managed table spaces itself. Okay, why? Because they reduce much overhead. Okay, previously people used to create dictionary managed table spaces. Okay, when we can create dictionary managed table spaces, let us see. Okay, before that, what is a dictionary managed table space? Let us see. Here we will mention some storage parameters. What are some storage parameters? Initial, next, min extents, max extents, and PCT increase, etc. What is this? Let us see by giving some values. 1 MB, 1 MB, minimum extents 3, maximum extents 20, PCT increase 100. What is the meaning of this one? Means first extent that will be allocated will be of the size 1 MB. This is first extent, extent number 1. Okay, this consists of blocks. When this is okay, the next extent size will be 1 MB. Why? Because we have mentioned here next as 1 MB. The third extent size will be 2 MB. Why it is 2 MB? We have given percentage increase as 100. That means first extent size will be 1 MB. Next also we have mentioned 1 MB. From then the extents which will be allocated will be getting increased with 100% size. That means after the completion of this extent, new extent will be allocated. That extent size will be 4 MB. After that, the next extent size will be 8 MB. Size will get 100% increase. That is double. Size will get double. What is the meaning of this one? Here size is getting increased or automatically double. It is getting double the size of the previous size. Why? Because we have given here size as PCT increases 100%. If we give 200%, 4 times it will increase. Understood the concept? Okay. That is more than double times. Okay, 2 double times. Okay, we have given 100 times. That means size of the extent will be getting doubled. Okay, these are about sizes of extensions. Okay, like this we can manage the size of a table space by and extensions. Here minimum extents are 3, maximum extents are 20. Like this, here 5 extents I have created. Like this we can create up to maximum 20 extents. Okay, if you want you can change this value, you can change this value. What is the meaning of this 3 minimum extents? Suppose I have created a employee table in this dictionary managed table space. In that I have inserted only single row. Even though I insert single row, automatically 3 extents will be allocated. Okay, which provides so many space complexities. Why? Because to insert, if I insert only one row, 3 extents are getting allocated. That means remaining space is entire thing is getting wasted. Is it good? For the sake of one row wasting the entire space? Not needed. That's why people started using locally managed table spaces. Oracle, that is Oracle has introduced locally managed table spaces. Okay, so when can we create locally managed table spaces and when can we create dictionary managed table spaces? Let us see. Our database can be created in 2 ways. One is manual method, other thing is by using automatic method called as DBCA, database configuration assistant. Manual method and database configuration assistant. When you create a database by using manual method, then in that we can create dictionary managed table spaces and locally managed table spaces. Okay, when we create a database manually. When you create a database by using automatically, you can create only locally managed table spaces. You cannot create dictionary managed table spaces. Okay, now what happens if we create a database manually? Okay, in our database there will be something called as system table space. Okay, For the system table space, there will be something called as extent management. If system table space extent management is dictionary, then in that database you can create dictionary managed table spaces and locally managed table spaces. Both type of table spaces you can create. Suppose in a particular database, system table space extent management is local, then in the databases you can create only locally managed table spaces. You cannot create dictionary managed table spaces. When you create database by using DBCA, the extent management in system table space will be local. When you create database by using manual method, okay, system table space extent management will be dictionary. Okay, so if a extent management is dictionary, then in this databases several table spaces might be there, TS1, TS2, like this. Extent management for all this should be done by the system table space itself, which gives so much burden on the system table space. Okay, in locally managed table spaces, the extent management of the table space is done by the table space only, not by the system table space. If it is extent management is dictionary, that is in dictionary managed table spaces, the extent management should be done by system table space. In locally managed table spaces, the extent management will be done by the table space itself. There is no burden on the system table space. As a result, performance of the system table space and our database will increase. Okay, it is better to use locally managed table spaces when compared to dictionary managed table spaces. Okay, think that you have already created so many dictionary managed table spaces. Can we convert dictionary managed table spaces to locally managed table spaces? Is it possible to convert? Yes. How can we convert? By using a PL/SQL procedure, that is DBMS. 1 minute. DBMS underscore space admin, okay, table space migrate to local, and in brackets give the system or any other table space which is dictionary managed table space. Okay, you can convert like this. This is PL/SQL procedure. And one more thing, if you see the entire hierarchy, okay, first Oracle OS blocks will be there. OS blocks in the sense 512 bytes OS blocks. Okay, operating system blocks will be there. Combination of OS blocks will create Oracle block. Oracle block size is by default 8K. You can give 2K, 4K, 16K, 32K also. Okay, continuous Oracle blocks. Continuous Oracle blocks combination is a extent. Combination of extent is a segment. Combination of segment is a table space. Combination of table space is a database. Combination of database, that is several databases can be present in one Oracle home location. These Oracle homes can be present in one server. Okay, this is the hierarchy. You can remember by using the command best. Remember every time, a segment, one segment can reside only on one table space. It cannot reside on more than one table space. So if a question is there, can a segment resides in two table spaces? No, it is totally wrong. Okay, a extent cannot reside on more than one table space. Two segments can reside on one table space, but one segment cannot reside on two table spaces. Understood the concept? So one more question, whenever we create a table, okay, by default how much size will be there for table, that is segment? By default 0. Whenever you insert rows, then extents can be allocated. Okay, similarly whenever a user is created, by default no privileges are given to that user. Okay, we should give separately. That we have seen in user management sessions. Okay, so in this session we are going to see the demo part now. Okay, so So first of all, let us connect to a normal user called as Oracle. Then export Oracle underscore SID equals to, I have created a database called as test. Let us connect to that test database. Okay. Now SQL plus is a tool to connect to the database / sysdba. Okay. Then give the command startup. Already database is up and running. So describe DBA underscore table spaces. What is meant by this? Let us see. This is a dynamic performance. This is a view, dynamic performance view, from where we can get all the details about a table space. So select table space name comma extend management from DBA underscore table spaces. So what it is showing? Select table space name comma extend management from DBA underscore table spaces. That means in this database you can create only locally managed table spaces. You cannot create dictionary managed table spaces. Why can't we create local dictionary managed table spaces? Why? Because in system table space extend management is local. So let us see how to create a locally managed table spaces. Okay. First, how to see how many table spaces are there? Select table space name from DBA underscore table spaces. So what is showing? These many table spaces are there. Let us create a table space. Create table space TS1 data file disk1 Aura data test ts1.dbf size 100 MB. Okay, we are not mentioning anything. By default its extend management will be local and also uniform, automatic mode will be there. So what I will do is, I will clear the screen first of all. So we will create a user, grant connect comma resource to u1 identified by u1. Okay, alter user u1 default table space ts1. Okay, we have created a table space called as ts1. Okay, so now this is a default table space. Now select username comma default table space from DBA underscore table spaces. So what it is showing? A spelling mistake. Select username comma default table space from DBA underscore users. What it is showing? One minute. So small spelling mistake, underscore is not given. So what it is showing? Select username comma default table space from DBA underscore table spaces. Okay, so what it is showing? There is a user we have created called as u1. For this u1 user, default table space is ts1. That is a locally managed table space with uniform auto option. So what we can do here is connect to that u1 user. Okay, create a table, create table emp number data type number, insert into emp values, and I will insert some numbers 1 2 3 4 5. Okay, similarly insert into emp select star from emp. What is meaning of this command? Insert into emp as select star from emp. That means, for example, in employee table 5 rows are there. Those 5 rows are inserted again into this employee table. That means previously 5 rows are there. Now there will be total 10 rows. Okay, what it is showing, 5 rows created. That means total 10 rows are there. Like this we insert some thousands of rows. When we insert thousands of rows, what will happen? Automatically extents will be created. Okay, and we can see the size of all the extents now. Now select, I will clear the screen, commit, so that it will be committed. Now describe user underscore extents. So what it is showing, user underscore extents. Select table space name, comma, segment name, comma, extent ID, comma, bytes by 1024 by 1024. What is mean by this? Bytes will show the size in bytes, divided by 1024 shows in kilobytes, divided again by 1024 shows in megabytes. Okay, from DBA from user underscore extents. So what it is showing? It is showing display of segment name is too big, so I want to reduce the display. How? Call segment name for A5. So what it is showing, slash enter means previous command will be executed again. It is showing that table space name is TS1. In that we have created a employee table. Extent ID starts from 0, 1, 2, 3 like this. Okay, it is showing in megabytes. Okay, what is mean by this? See, up to 16 extents, from 0 to 16, 0 to 15 it is 16 extents. All the sections are created with the size 64 KB. Why? Because it is showing in megabytes, it is showing 0.06. Okay, when this all the sizes of all the extents completes 1 MB, then the next extent size will be 1 MB, 1 MB, 1 MB. It will be growing like this. This is locally managed table spaces automatic method. Now let us see locally managed table space with uniform method. For that, what I will do is, I will create one more user, grant, before that I will create a table space, create table space ts2 data file disk1 aura data test. Sorry, already ts1 is created, so I will create with a different name, disk1 aura data test ts2.dbf, size 100 MB. Okay, extent management local and uniform size. That size we are mentioning, uniform size 40K. What is the meaning of this one? Insufficient privileges. 1 minute. I will connect to sys user and I will give this one. So a table space called ts2 is created. In that, extent management is local, extent size is uniform size, that is 40K. Okay, so what I will do, I will create one more user, grant connect comma resource to u2 identified by u2. Now alter user u2 default table space ts2. That means if we log in as u2 user, if we create some tables, that data will be, actual data will be stored in ts2 table space. Okay, so select username comma default table space from DBA underscore users. So what it is showing, spelling mistake again, select username comma default table space from DBA underscore users. So what it is showing? For U1 user default table space is TS1, for U2 user default table space is TS2. Okay, so now connect to U2 user, create a table, create table T, data type number. Okay, now insert into T values, I will insert 1. Okay, next insert into T, select star from T. That means again one row created. That means already in T table one row is there, again one row is added. Now it is having 2 rows. If I slash enter means previous query will be executed again. When I execute the previous query, already 2 rows are present in T table, again those 2 rows are recreated. Now enter, 4 rows will be there. It will show 2 rows created like this. Like this we are inserting so many values. After that I am giving commit. Okay, now select count of star from T. These many rows are present in T table. Okay, next. Now next select table space name comma segment name comma extent ID comma bytes. Let us see in kilobytes only. Divided by 1 time divides, it will show in kilobytes. 2 times if you divide by 1024, it will show in megabytes. Okay, from user underscore extents. So what it is showing now? If you see here, table space name is TS2, in that segment is T, extent ID starts from 0, size of the extent is 40 KB. Okay, like the 16 extents completed, 20 completed, everything completed. Even though 163, 164 extents are created, it's still showing the size as, it is creating the extent with the size as 40K only. This is called as extent management local with uniform option. Now let us see extent management dictionary. Anyhow you cannot create dictionary managed table spaces in this database. Why can't we create? Why? Because here extent management of system table space is dictionary, local. In this database, extent management of system table space is local. Hence you cannot create dictionary managed table spaces. Okay, so let us start one more database. 1 minute. So let us open one more database. Database name is EMP. Okay, slash as sysdba startup. Already database is started. So select name, select table space name comma extent management from DBA underscore table spaces. I have created this database by using manual method. So this dictionary managed table space is created. Now let us create a dictionary managed table space. Create table space. Here extent management of system is dictionary, so you can create dictionary managed table spaces. Create table space DTS data file disk1 ora data emp dts.dbf size 100 MB. Next, initial storage, default storage initial 1 MB, next 1 MB, initial 1 MB, next 1 MB, min extents 3, max extents 20, min extends 3, max extends 20, and PCT increase 100. Okay, then extent management dictionary, extent management dictionary. So here spelling mistake is there, small spelling mistake. We should write here max extents extent management dictionary. So 1 minute. Shit. No space should be there between PCT and increase. Then extend management dictionary. Like this you can create a dictionary manage table space. Now select table space name comma extent management from DBA underscore table spaces. So what it is showing, DTS table space is also dictionary manage table space. Now grant connect comma resource to U1 identified by U1, alter user U1 default table space, default table space, alter user username, default table space name. Okay, now connect to U1 user. This is separate database. Okay, so in that create table T1 okay, T1 data type number. Now insert into T1 values, insert like this. We'll insert into T1, select star from T1. Okay, commit, select star, select table space name comma extent management, select table space name comma segment name comma extent ID comma bytes divided by 1024 divided by 1024 from user underscore extents. So what it is showing, call table space name, call segment name for a 20. So what it is showing, so in DTS table space T1 segment is there. Even though you insert one row or any number of rows, by default these 3 minimum extents will be created. Okay, when you insert too many rows, the size will get doubled. How to check that one? Again insert few more rows, insert into T1, select star from T1. Give commit. Commit completed. Now select table space name comma segment name comma extent ID comma bytes divided by 1024 divided by 1024 from user underscore extents. So what it is showing, the third extent is allocated, its size is 4 MB. Like this, size of the extents will continuously increase. Okay, so this is how to convert, this is how to create a dictionary managed table space. Now let us see how to convert a dictionary managed table space to locally managed table space. Okay, for that, select table space, select table space name comma segment name comma extent id comma bytes, say table space name comma extent management from dba underscore table spaces. So what it is showing now, table spaces. What it is showing, select tables, 1 minute, connect slash as so give the same command. So what it is showing, system is dictionary, DTS is dictionary. How to convert? First alter, first take all the table spaces to read only mode. All the table spaces in the sense user data read only. Okay, then alter table space sysox, take sysox to offline. Then alter table space DTS read only. Then you cannot take temp or undo table space to read only state. So alter session, alter system enable restricted session. What is mean by restricted session? See, whenever database is in restricted session, where restriction mode is enabled, only DBA can perform his activities. Non-DBA cannot perform their activities. Even the users who are having restricted session privilege can perform their activities. Remaining users cannot perform their activities. So if we change like this, execute dbms underscore space admin dot table space migrate to local. The name we are giving system. Like this we can convert by using this. The system table space, previously if you see, extend management of system is dictionary. Now if you see, system extent management was changed to local. Like this you can convert a dictionary managed table space into locally managed table space. So this is about our storage management. In if a system table space, if in a database, if system table space extend management is local, you can create only local managed table spaces. If system management, if in a database, if system table space extend management is dictionary, then in that database you can create dictionary managed table spaces and also locally managed table spaces. Okay, so this completes our storage management classes. Okay, hope you enjoyed the session. Thanks for watching this video.